All right, I hope everyone is still with us. We've got the final part of our session, which is going to be, I think, another super dynamic fireside chat and a thrill for me as well. It is my pleasure to welcome on stage CEO and co-founder of Cyclize, Maike Lambarth. Good afternoon. How are you doing, Maike?
Hi, I'm fine. It's amazing to be here and to feel this energy and collective, we are many people working for the same goal.
Yes,
that is
and the sun is shining on us today as well. So, we've gone through a lot of topics in the first panel and the last fireside, and I'm really, really interested to get your perspective, especially from the point of view of Cyclize, which is a startup, so really doing things on another side or perspective. And firstly, I want to cover a point about the economic pivot, because I think your journey started with a research project on making marine diesel, but you eventually realized that while the tech worked, the economics didn't. So here again, coming back to the business model point, you pivoted to using plastic waste as an energy source. What was the light bulb moment for you where you realized that solving the waste problem was key to making decarbonization actually affordable in the chemical industry?
Well, as you said, I was a researcher at the university, but I'm also an engineer by background. And as an engineer, you always want to make things working. So it always was important to not only do specific research because it is fascinating to research things, but we also had the ambition to create something that would work in reality. And that's why we did economic analysis very early on, so a economic analysis. And by doing that, we realized if we start with like air and water and turn that into diesel, ship diesel, it works from a technology perspective, but you need to pump a lot of electrical energy into the system in order to break down the or to harvest the CO2 first, then to break it down into carbon monoxide, then to break down the water into hydrogen, match that together, and then make diesel out of this. So technically, all of these steps are available, but the costs that are coming up by producing this fuel would be like 30 euros per liter if we are using the efficiency that we have in the lab today. So 30 euros a liter, no one is going to pay for that. It's not working?
Yeah. Or it's working. Okay.
It's working. Great. So it was clear that this is not a pathway that would succeed by its own. So we checked for other processes because the ability of the plasma reactor that we were developing was to turn waste or carbon from a waste source, which was CO2, back into the loop. And that is a fantastic ability that we wanted to use. So we added plastic waste to the CO2 and lowered the efficiency, the electricity demand by factor 8. And then it worked also from an economic perspective on paper first. So the task was then to scale that into an industrial scale and to make that happen for the economy.
Amazing. I hope Justine's listening, because this is exactly what she was asking for, scientists with business models. And also in the plastic and recycling industry, I think there's also a massive cost and energy spent in sorting different types of plastics, right? Can you talk to us about how you overcame this issue and how removing the need for pre-sorting change the industrial math?
Well, when we look into recycling technology, there is a huge variety of technologies available, and I think that is one of the beauties, and we need all of them. And typically they have a space where they operate very well, and that typically comes with sorting. So if we go into mechanical recycling, for example, we need to sort the plastic waste quite well, but then we need very little amount of energy in order to recycle that. And the more unsorted the waste stream gets, and sometimes that's due to the product. So if we are looking to all the shoes that we are wearing today, everything is glued and stick together. So that's something you can unsort very hard, because it is in it as it is a product, and it's hard to design a shoe where nothing is glued and stick together, right? So there is a variety of different recycling technologies that addresses different sorting waste streams. And in our case, we're using plasma technology, and plasma you can imagine like a molecule chipper. So it's shredding down those long and complex waste molecules into what we call carbon monoxide and hydrogen. And those are really the basic building blocks, like a Lego block, where the chemistry industry is building whatever product that we're using today anyway, is making out of these. So it is a basic building block of the existing value chain, and we can shred down those complex and unsorted waste streams and bring them back into the circle. So whatever is working for mechanical recycling or depolymerization is perfectly fine. The rest, like the waste of the waste, that is the perfect feedstock for our technology.
And maybe to kind of bring it home, because I think you're complementing the last two conversations really well. You have boots on the ground, building a new solution. And I want to talk about how you are overcoming this sort of death valley of scaling. Because they say typically software is easy and hardware is hard, right? And you are in the hard space. Some startups start with just a click of a button because they don't need any physical plants that they need to build. You, on the other hand, are building physical plants and hardware. What are some of the, based on your experience, what are some of the observations you've made in how industry and policy can work together to appease some of this difficulty in scaling?
Well, something I like to say is that software is easy to build, but it's hard to sell. And hardware is hard to build, but then easy to sell, because you really solve a physical problem. And we do have a physical problem that we are facing, so we do need physical solutions. And therefore, it is hard in terms of financing strategy to build the first plant that is running in an industrial scale-up. And that's what we are doing at the moment, where we are also doing fundraising for at the moment. But then once this plant is running economically, and we don't need a green premium or anything, so this is easy to sell afterwards, because then we can say, okay, we have proven this in an industrial scale, the plant pays for itself, we have customers, this is a huge problem globally, and we have a solution for it. So it is this typical valley of death that we are in the middle of it at the moment, and that's a very interesting phase to be at, but I'm also very, very optimistic that this will work out. Of course, I mean, just look around, we're so many working on the same issue, why we shouldn't succeed?
I'm equally optimistic and totally rooting for you. Just conscious of time, for the last question, I wanted you to explain to us in more detail how your solution is helping current players, stay intact. Because I think one of the biggest perceptions around transition is that current incumbents would need to completely overhaul their current infrastructure, which means billions of dollars in costs, right? And I think your solution is offering an alternative to this and making this burden a bit less. Can you tell us a bit more about how exactly you are doing this?
Well, at the beginning we thought what part we could offer to this transformation. So we realized that in a linear use of carbon, where we are in today, we have two ends that are not connected. One is the chemical industry, where everything starts, and 96% of all the products we're using are attached to the chemical industry, and then the waste industry that is at the end of the line. And both are really big industries with a long history. They have both their own specifications, and of course they do know each other, but they struggle meeting each specifications, like who is in the responsibility to go a step towards the other one. And we see ourselves as this bridge builder to meet both of the specifications. So we do know what is the available waste quality, in what shape is the waste, so on and so forth, and we turn that into a syngas that meets the specification of the existing chemical value chain as well. So it is our responsibility to bridge those two worlds together, where they're struggling with at the moment for themselves, which is a pity, but I think it's also nice for us to find this gap solution here.
Amazing. So working with what they have in order to diminish the loss, and also maybe create an incentive for them to jump on board, right? That is truly amazing. Thank you for what you're building at Cyclize. It's making me very optimistic for the future. And I am also rooting for you to get out of your Death Valley phase. Yeah, everyone, please welcome me in, or join me in giving Maike a round of applause.
Thank you.
And that is the end of our session. Thank you all so much.